Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Welcome to this class, Introduction to Blockchain Technology. This is a presentation of Coding Bootcamps. Introduction to Blockchain Technology, how blockchain works. A little bit about our instructor. Jim Sullivan has a BS in Electrical Engineering and a Master's in Computer Science, also holds an MBA. Jim is a Master IBM instructor, an O'Reilly media instructor, and a senior blockchain developer at BC Webmakers. As a software engineer with nearly 20 years experience, Jim leads an expert team in blockchain development, cloud application development, and is a safe agile methodologist. Jim is an expert in blockchain platforms like Hyperledger, Ethereum, and Corda. There are no prerequisites for this class. Here's a list of topics we'll cover: the introduction to the blockchain technology and how ledgers work, blockchain structure and types, blockchain operation and mining, blockchain cryptology, blockchain consensus, distributed blockchain networks, blockchain versus database, the first and the second generations of blockchains, popular blockchain products, essentials of cryptocurrency, cryptocurrency fundamentals, blockchain regulatory structure, and we'll wrap up with blockchain use cases. You will take away from this class a solid learning, a solid knowledge of blockchain and technologies and how to apply it, and in where blockchain technology is applied and where it provides business advantage. Some follow-up classes: Introduction to Blockchain Cybersecurity, learning about Solidity programming, learn blockchain development with Corda, Hyperledger Fabric for developers, Ethereum blockchain development, Hyperledger Fabric for administrators, Hyperledger Sawtooth for administrators. Once again, thank you for taking this class, and follow us on social media. We will talk in the session. Welcome to this presentation of Introduction to Blockchain Technology, presented by Coding Bootcamps. This is the Introduction to Blockchain Technology, the history of blockchain technology, and Bitcoin. About our instructor, Jim Sullivan is a senior blockchain instructor and developer with BC Webmakers. As a software engineer with 18 years, Jim leads an expert team in blockchain development, including DevOps, cloud application development, and the safe agile methodology. Jim is an expert in blockchain platforms such as Hyperledger, Ethereum, and Corda. So a little bit about blockchain. So most people really heard about blockchain when Bitcoin made its run in 2017. We all remember that the price per Bitcoin made it to about $20,000 per Bitcoin, possibly slightly over that. Some people will be surprised, but Bitcoin and blockchain are not the same thing. We all heard a lot about blockchain when the price of Bitcoin was approaching $20,000. A blockchain can run without a Bitcoin. So a Bitcoin is merely just an application that runs on top of a blockchain. Bitcoin cannot exist without a blockchain because Bitcoin, again, is the application that runs on the blockchain. Blockchain technology exists well beyond Bitcoin or any other cryptocurrency. So we see blockchain technology used for tracking inventory, tracking the medical records. It can even track mortgage. We hear some products out there that will secure your mortgage. Well, a blockchain can also secure your mortgage or any other types of paperwork. notary, anything like that can be tracked by a blockchain. Also, inventories and also the the inventory chain can be tracked by a blockchain. Therefore, blockchain is the underlying technology that secures and verifies asset transactions. Bitcoin is a digital currency. So Bitcoin is open source. So therefore, the source code can be downloaded and run on any computer. There is, with Bitcoin, anonymous. So we see often with public blockchains anonymity. One of the big attractions of Bitcoin, because it is a public blockchain, in order to conduct transactions, we don't want everybody to know who is conducting the transaction. So therefore, only a wallet address is used. Therefore, securing blockchain and by anonymity. And it's also transparent. So all of blockchain, well, all of Bitcoin transactions are out in the open and can be viewed by anybody. Anybody can look over what the transaction was, and if anybody has any questions, they can look further into it. So Bitcoin was founded in 2009 by Satoshi Nakamoto, and that's actually a pseudonym, and nobody really knows the true identity of Satoshi Nakamoto. The Bitcoin's website is bitcoin.info. And Bitcoin, there are several what they call blockchain explorers for Bitcoin. You can take a quick look at one of them. You see here, just let me refresh this. Here is, we can see the current price of Bitcoin, and we can see here a transaction. If we navigate into a transaction, and we can see some information about this particular transaction. And here we can see the hash of the transaction, fees, and we can see here, this is the actual block. So if we come down here, we can actually see the transactions. So you can go out here and watch Bitcoin transactions. This is just one of many blockchain explorers. And you can see here in the transactions, they are quite anonymous. The transactors are only known by their what they call wallet addresses. But we can see how much Bitcoin was transacted. BTC is the abbreviation for Bitcoin, and you can see the date and the time that the transaction was confirmed. So this is currently the transactions that are in this most recent block. And again, Bitcoin is the largest cryptocurrency. And here's another website, bitcoin.org. And it's important to know that nobody owns Bitcoin. It is community based. It's maintained by the community. And anyone can join the community. Something comes up quite often. What gives Bitcoin their value? And that is a tricky question. You never physically take possession of a Bitcoin. It simply gets sent to your wallet. It's a digital entry in your Bitcoin wallet. However, though, what gives Bitcoins their value is the same thing that gives gold, silver, or even dollars their value. It's the demand for them. And gold, silver, diamonds are not liquid assets. They are assets, but they're certainly not liquid. They must be exchanged for cash, in most cases, to purchase goods or services. Bitcoin was first discussed in a white paper that was issued by Satoshi Nakamoto in 2008. And this is an interesting white paper. It's called Bitcoin, a peer-to-peer electronic cash system. It is very interesting. It is surprisingly short. So we can actually take a look at the white paper. If we look here, we can go back to the beginning. And you can download it. You can simply go out and search for it. You can see they make the introductions, discuss some transactions, discuss one of the big problems early on with this kind of currency was the double spending. And you can even see how they begin to discuss how they will prevent double spending. And we can see here how hashes come in and timestamps, the proof of work, which we'll actually talk about, the network, and how space can be reclaimed. And again, the most interesting part of this white paper is how brief it is. It is only 8 pages. I guess 9 if you include the references. But the conclusion is right there on page 8. So I always found that interesting, that something that made such a big impact had its white paper that was so brief. And again, Bitcoin is the application that runs on top of the blockchain. So we see a lot of examples or a lot of analogies. We could see that we have applications like Google or Yahoo. Those are applications that actually run on the internet. We can see here's a reference to Instagram. Blockchain can be set up as a completely secure peer-to-peer, person-to-person transaction system for transacting digital cash or any items of value. So, and we see here transactions can be as simple as using a smartphone or any device, so an app. So the assets are exchanged electronically on an application. We always have to have something like that. And blockchains run in a truthless environment. So this allows for transactions to be completed without providing a third-party trust. Quite often, anytime 2 parties need to transact, a third party like a bank is needed to provide trust, to operate, to update the ledgers. Well, with Bitcoin transactions, we don't need that environment because the ledgers are updated automatically and you can see them updated instantaneously. So again, we see here how the vision for blockchains will be running on the internet, just as today on the World Wide Web, the World Wide Web runs on the internet. So a lot of people don't know the World Wide Web is actually a section of the internet, and blockchains would also have their own section of the internet as well. And blockchain, with its mix of cryptology, so it secures transactions using cryptology, transparency, also distribution. It results in a powerful new technology for security and immutability. So the way that the blockchain is constructed allows for distribution throughout the world. And just like we saw in the Blockchain Explorer, anybody can view the transactions. The number of users can go up and up because blockchain is built in a distributed type of architecture. So you can download the Bitcoin ledger, and then that would allow more users to participate. And it does decrease the costs of transactions because we transact directly on the blockchain, so we update the ledger ourselves. And this provides for less expensive transactions and paves the way for what we call micro transactions. Today, micro transactions, very, very small, maybe fractions of a dollar, even below 1 cent, really cannot be completed because of fees. And a lot of times the fees really just involve updating the ledger. So before blockchain, microtransactions were just too expensive. But today we actually see that we are able to use our applications for transacting in cryptocurrency. And in many ways, blockchain is already being called the technology of the decade. We'll all see. It is quite secure.
Thanks for watching. Feel free to add your questions as comments down below.
It is a significant advancement, and we don't know if any of these statements, we don't know how true they will be, but their chances are we will be affected by blockchain in some way. And one of the key things about blockchain, which makes it very attractive, is it's creating new ways to solve old problems. So with the transferring money, before we just accepted that we needed a PayPal, we needed a bank to facilitate us in transferring money. Well, with a blockchain and a Bitcoin, we don't need that. We can update the ledgers directly. We can track data and files. So just like we track Bitcoin, we can substitute in there data like music, music files, or files like the deed to a house or the title to a car. Automatic contract execution. So blockchains can also be used to execute contracts. We know we can complete transactions on a blockchain, and the next step there would be executing the terms of a contract on a blockchain. And that's actually called a smart contract, which we'll talk about later. A few things about blockchain. It is decentralized and distributed. So a decentralized network in this case means there are full copies of the Bitcoin application on what we call nodes throughout the world, and they are absolutely identical. So you download the Bitcoin ledger, you download the application. Every tier, or every node, every computer is running the exact same software with the exact same data. The data is immutable and incorruptible. We'll talk about later how we actually, why data is immutable on a blockchain and why it is incorruptible. Highly secure. Well, for these reasons alone here, the immutability and incorruptibility, that goes to high security. And the blockchain nodes contain replicated data. So since every node on the blockchain has the same data, if any node would go offline, we would have another node ready there to take its place. And data logged according to the community agreed algorithm. So the community actually makes the rules on how the blockchain will function. And it can be permissionless or what we call permissioned. So on a Bitcoin, everybody has the same access in Bitcoin. Everybody can view a transaction. Everybody can execute a transaction. There are blockchains that run what we call permissioned models, where we actually have roles and we have permissions to execute transactions. And we'll talk about that later. And we can see here again a depiction here, a workflow of a transaction on a blockchain. One user wants to send money to another user. That transaction is broadcast on the network. People we call miners add the transaction to a block. The block is broadcast to every other party, and those in the network approve the transactions, and then the new block is eventually added to the blockchain, and the updated ledger moves that money from A's wallet to B's wallet. And so if we think about it in some way, what's one simple way that we can describe a blockchain? Well, it's been talked about that it's almost like a spreadsheet. So the whole ledger could be like a single spreadsheet. So imagine a spreadsheet distributed on computers throughout the world, the same spreadsheet, and on all of these computers, somebody is maintaining the spreadsheet, and they're updating the blocks with various transactions. So since everybody has the same copy of the spreadsheet, we'd have to say to ourselves, well, even though we are updating with the same general information, the spreadsheet copies could get out of sync. So they may differ slightly. So therefore, a consensus method is needed. And what happens with the consensus method is we all enter the transactions, and there is a consensus algorithm, which we'll talk about shortly, that allows somebody to be the first one uh, to display the transactions to the whole network, and then the network can vote. And once that community votes, everybody resyncs or gets a fresh copy of that blockchain. So that's what we call the consensus method. Uh, Proof of work is the current consensus algorithm or consensus method of Bitcoin. It's very popular for blockchains. Proof of work started as a solution to prevent computers from sending junk mail. The idea was that computers that may potentially send mail would have to perform several calculations first before they could send anything. Well, you're only going to send something worthwhile when you have to perform these calculations ahead of time. So that was the idea, and it was so this proof of work had already existed, and then proof of work was identified as a excellent consensus solution for Bitcoin. Generally today, there are considered to be two generations of blockchain. Blockchain first generation would be a Bitcoin. Blockchain second generation is where we can actually write applications on the blockchain. So a first generation blockchain, well, let's just say that with Bitcoin, it only manages its native token or its native coin. It doesn't do anything else. So that's a good example of a first generation blockchain. Blockchain 2.0 provides tools that'll take action on the records that we keep. So not only can it generate actions such as the parties, certain conditions for the parties that have to be met before any kind of transactions can be completed. You can also transact any kind of asset, not just the blockchain's native token. So second generation blockchains provide us the method to manage any type of asset, a home, an automobile, the deed to a home, a birth certificate, possibly even a driver's license. And smart contracts are programs that actually run on the blockchain that take action on the records. We'll talk a lot more about smart contracts coming up. And so the distributed ledgers that run on the computer hosts, they're called nodes. So they are computers that are running the blockchain software and the blockchain ledger. So nodes in general contain a copy of the full blockchain. So that is true with Ethereum. That is true with Bitcoin. There are some exceptions to this when we start talking about private blockchains. And this distribution allows the blockchains to be always up and running. So blockchains are resilient. In blockchain, the distributed users are called miners. So you might hear the term miners or mining Bitcoin. They are maintainers of the network. So miners maintain the blockchain and keep it updated and keep it organized. Miners update pending transactions on their individual nodes. And miners compete to verify the transactions. So once verified, the transactions are then relayed to the rest of the nodes on the blockchain. So that data is sent out. That's that resynchronization that we just talked about. And miners are paid a reward when they are the ones that are voted on as adding the transactions. And when they're paid a reward, they're paid in the case of Bitcoin, the miners are paid Bitcoin. And for other blockchains, they're paid in that native token. And so this is how new cryptocurrencies are minted. And then once verified, these transactions become a permanent part of the blockchain. There are two There are several good videos on blockchain, and these are just two of them right here. So please, if you can, take a look at these. Take a look back at your learning materials if it's easier to get it from your learning materials. And we can see here, so Bitcoin is considered the first blockchain. That's probably true, although there are some that would disagree with that. And we talked about this before, that nobody takes physical possession of Bitcoins. So Bitcoins are actually never even downloaded. They will remain, they actually are entries in a ledger that you can view through your Bitcoin wallet. And the ownership of the Bitcoins, just like we saw in the white paper, is tracked by the Bitcoin blockchain application. So again, if user X needs to pay user Y 2 Bitcoins, the Bitcoin blockchain is updated with the new ownership. And we go back to that white paper, you can see here, it's really the change in ownership that is tracked on the blockchain. So we could see here the ledger entry would be something like user X has now 2 fewer Bitcoins and user Y has 2 more Bitcoins. If we are using, this is we can see here one way of transacting, in this case, Bitcoin. So we can see here we can actually scan. You can see the address here. My wallet address is quite long and sometimes it's hard to copy. So these QR codes really help. And so the wallet itself does not actually contain any Bitcoin either. It contains your credentials to access the Bitcoin application. And the QR codes just simply make the transaction a lot faster and a lot simpler because everything can be done by an app. And you can see here the user's wallet address. This is called your public key. And everybody knows your public key, just like your address. If somebody wants to send you a letter, they need to know your address, and your address is public. In order to decrypt a transaction, you need what's called your private key, and your private key is hidden within your wallet. Your private key decrypts the transaction. So it's a two-key, called what we call two-key encryption. And we can see here again the anonymity of a Bitcoin transaction. We can see here the addresses, the input address, the output address. We could see the amounts here, any fees, other information. Again, this comes from a blockchain explorer. And just something to think about in general, if you buy a candy bar from a store with cash, what ledgers are updated? Well, think about that. If you buy a candy store with a credit card, what ledgers are updated? What would be more expensive? So in my opinion, I'm thinking with the credit card, because we have that third party. The third party's working in the cash too, but we have that third party working immediately, making all those updates. And just for some work, or if you want to try something out, go to blockchain.com Explorer and look at some of the Bitcoin transactions under the Bitcoin logo. You can actually see these are actually blocks right here, and then you can navigate into the blocks and see the transactions. And again, we can see a transaction here. Again, we navigated in, and we can again see. Well, this says unconfirmed transaction, interesting, but we can see the transactors here, and you can see their wallet addresses, and you can see some information about the transaction. So to summarize, we looked at the inspiration of Bitcoin, and we had our introduction to blockchain and some of our blockchain transactions. So here's our assessment. So please go into your learning materials and take a look at the assessment questions. And here are additional resources. So you can get more information from your learning materials as well. And if you're interested in more blockchain training, Here are some additional courses that are offered. And in our next session, we are going to look at the impact of.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Ledgers on society. Thank you. Welcome to this lesson on Introduction to Blockchain Technology presented by Coding Bootcamps. And this is the impact of ledgers on society. We've had our introduction about the instructor, some information about the instructor. So to recap, what we learned so far are some basic high-level architecture of blockchain. We learned about Bitcoin and its origins. And so now we're going to talk about ledgers. So at its heart, a blockchain is a digital ledger. So we can see here a very, very simple ledger. And so how do ledgers work? Well, they list what entry, the entries on here list what somebody owns. So you can see here there are accounts, and we do indicate how much is owned by that account. So when we update a ledger, actually nothing is changed. Another record is added to the ledger. So ledgers tend to be append only. And then we find out a balance simply by summing up all of the entries for a particular account. And although ledgers seem quite simple, they've had a great impact on society. So as we can imagine, back in maybe the hunting and gathering days, people did not own much more than they could carry. So there was no reason to really write down what somebody owned. But once we began to advance into the agricultural age, suddenly we began producing more than what we needed. At that time, then, it became necessary to actually indicate or write down what you owned. And it was in these times that record of ownership or ledgers came into existence. And once people knew what they owned and they could prove it, this facilitated trade. And then the double entry ledger made it possible to facilitate trade using third parties to maintain the ledger for two or more other parties. So this type of ledger facilitated not only trade between the villages, but also trade between nations. So if we didn't have that double entry ledger, chances are you were very limited to just your local village or just a few people, because the updating the ledgers were fairly simple, fairly straightforward. So you couldn't go beyond those that you actually know. So once trade between nations was facilitated, that led to technological discoveries. It gave rise to financial services, banks, other types of insurance services. And so ledgers have truly impacted society. And there are those that would say that blockchain is a triple entry ledger. And we can take a look at that. So we see here that a blockchain does have a ledger that does have, although it's not in this straightforward form, does have the double entry, the debit, the credit, who had the asset and who has it now. How much of the asset did person A have, and then what did they give to person B, and how much more does person B have now? That is part of the blockchain. But then there is an introduction of a mathematical hash. And we're going to see why this hash is important. Essentially, a hash is a digest of data that's very, very sensitive to changes. And this is one of the ways that we actually secure our blockchain, and one of the ways that we say it's immutable. Since a hash is very sensitive to changes, we'll know if any changes are made. So on the blockchain, transactions are written into a block, and a block is essentially a file. So block size is limited on most blockchains, and it's usually limited to 1 megabyte. There can be exceptions to that, and that's usually done to prevent runaway blocks. Around 25 transactions go into a block, and again, that's just the keep order. Once we get into 25, 26, it's time to validate the block and then start on the next block. So blocks are added to the blockchain. So a block again contains the listings of the transactions. So blocks are never removed or updated. And if a block could be updated, we would no longer trust it. So again, we can see here some similar types of transactions that may be listed in the blockchain. That Bill sent Mary $14, Tom received $6 from Peggy, and so on. So these are the types. This is a simplified view of what we might actually see in a blockchain block. We talked about this a little earlier about double spending. So double spending with any electronic asset has always been an issue. And the way that we are addressing it here is once a transaction is completed, the transaction must be validated. So we can see in this case that Sam has one coin. I'm calling it N coin here. And Sam completed 2 transactions with the same coin. And obviously here, one of these, Sam gives away his one coin to one of these other accounts, and so Sam cannot use it twice. So one of these transactions, most likely this one here, would then be declined. And so what we really talked about is that function of the ledger and how ledgers help advance society, a brief history of how ledgers advance society. And we talked about how Bitcoin addresses double spending and the nature of a block. So please go in and take a look at this assessment a little further, and maybe we could talk about a little here. What is the basic functionality of a ledger? Think about what that is. And how did ledgers help society advance? So let's think about that. And the double spend, how is that solved by the miners? Because we talked about miners in the previous lesson. Please, for more resources here, please take a look at this additional information. Please check your learning materials. And again, please check your learning materials. And if you're interested in more training, please take a look at these additional training resources. Our next session, we are going to talk about blockchain structure and types. Thank you. Welcome to this lesson on Introduction to Blockchain Technology, presented by Coding Bootcamps. In this lesson, we're going to discuss blockchain structure and types. We've already covered about the instructor, so please read more if you have any other interest. And in the previous lessons, we learned about the history of Bitcoin, the history of ledgers, some high-level architecture of blockchain. Now we're going to talk about the blockchain structure and the different types of blockchains. So blockchains track data. So just like a ledger tracks data, blockchains track data in the same way. A big tool of the blockchain are the hashes. So hashes are generally known as digests of data. And so with these hash algorithms, so there are hash algorithms, different ones will produce different outputs. Any data that is stored in fixed, when we talk about a digest of data, we can take any string, any alphanumeric string, and essentially convert it to an alphanumeric string of fixed length. So it will convert any data. It could be a sentence. It could be one letter. It could be several volumes of a book. They all would be hashed to the essentially an alphanumeric string of a fixed length. And there are different hash algorithms. So there's MD5, SHA-1, SHA-256. Hashes are very sensitive to changes. So if there's any change to the data that generated that hash, the hash is going to be different. So that sensitivity of change is probably the #1 reason to use hashes if you want to know if any of your data has undergone any kind of changes. So let's take a look at some examples. So this string or this sentence here, what is blockchain, followed by the character here, the question mark character, hashes, we're using an MD5 hash algorithm. This is its 32 character hash right here. Right here, this number 1 million with the commas hashes to also 32 characters. We can see it here. A 0 hashes also to 32 characters. And this paragraph also hashes to 32 characters. So this is the MD5 hash. And again, different hash algorithms will have different outputs, but they will all follow those same rules, that it will take an input and create an output of fixed length. Hashes are asymmetrical, so there are no inverse hashing functions. So in other words, we can't apply a formula to a hash and then return the input. There is no formula to reverse the output and get back what was input into the hash algorithm. So we cannot go back to this previous, we cannot take these hashes necessarily and get back what we put in. Sometimes you would see some applications do have that reversing function, but just consider that something more of a learning type of approach. Hashes are considered to be asymmetrical. So we could take a look here again how the hashes work as far as the blockchain. So the hashes are actually become part of a next block. So if we look here at block 40, block 40 has some data in it, some transactions. So we can see here the list of transactions added. And there is a proof of work hash that is generated from these transactions. And this proof of work then becomes part of the header for the next block. So we have block 40, we're going to block 41, and we see all these transactions, we see its output hash, and this output hash is in the header of the next block. So this is actually what we're talking about, the chain. This block now knows its successor because it's looking for its hash in the next block. So if anything here would change, these two hashes would no longer match. And the same thing here. There's a list of transactions again in this block. We have a new proof of work, and that proof of work then becomes the header in its successor block, which is 42. Another way to look at it here is, and this is more of an abbreviated way, we can see here Bob and George had some kind of Bitcoin transaction. Jay and Mark, the same thing. And a hash or block signature was created, which happens to be the header for the next block. Well, if somebody would go in and tamper with, so before in the previous, we saw George had, well, at least received 100 Bitcoin. If somebody went in and changed it so George would receive 500 Bitcoin, that would change the hash. The hashes would no longer match, and then this block then would be dropped, and a ledger from another node then would be brought in to overwrite this current ledger, or this current block. So let's talk a little bit about the types of blockchains. So we talked a lot about public blockchains. So with public blockchains like a Bitcoin or like an Ethereum, you have a fully distributed ledger. So you have the ledger on several computers, several users' computers throughout the world. Again, these computers are called nodes, distributed throughout the world, fully open, permissionless. Everybody has the exact same access. They can manage any type of asset or data. So this is...
Thanks for watching. Please like and share this video.
Not necessarily Bitcoin, but say this is Ethereum. Each node has full access to the full ledger, and they are immutable. So we saw the immutability. Anonymous, so we saw a lot about anonymity. Visible to all users, and the consensus is based on community, and smart contracts. So Bitcoin's a bit of an exception to certainly this point, any type of asset or data and smart contracts. Well, in order to work in a private business, not all of these attributes here would be welcomed in a private business. So if we wanted to set up a transaction system or a blockchain between businesses or within one business, we probably would not want all of those same attributes. We might not want fully open. We might not want permissionless. Each node having access to the full ledger. We don't want anonymity. Most likely we don't want that. We don't want the visibility to all users, and we don't need consensus of the community. We do want a distributed ledger, managing any type of asset or data, immutability, and smart contracts. So private blockchains have the distributed ledger, and data in this case, data can only be seen by those who need to see it. So there are permissions in a private blockchain. So examples of some private blockchains would be Corda, or Hyperledger Fabric, or even Hyperledger Sawtooth. They can manage any type of asset or data. Yes, that's what we want. The ledger is only available to those who need to see it. That's what we want. We still want the immutability. We want known users in this case, because for the enterprise, we want to know who is conducting. We want to know who's conducting the transactions. Visibility based on role. So again, depending on your role, what data you can see. Fewer nodes, and again, known users, and we do want smart contracts. And there is another blockchain type, sometimes called permissions. An example here of this one could be Ripple, and it's considered the permission blockchain. Again, distributed ledger is desirable, can manage any type of data or asset that's desirable, immutability, smart contracts. And the fully open, permissioned, each node has access to the full ledger, anonymity visible to all users. These would be undesirable in a permission blockchain. So again, permissioned blockchains are structured in a very, very similar way private blockchains. So again, the known users, we still have the smart contracts, we still have the immutability, but again, permission of visibility, permission to access. And some popular public blockchains are Bitcoin, so the largest blockchain, and that's probably still true. Ethereum. So Ethereum calls itself more of an application platform or an operating network. So we know an operating system like a Windows or a Linux, that you can run many applications on an operating system. Well, with Ethereum, it calls itself an operating network. So you have a scaled up version of what we just talked about, the operating system. So you actually have different computer nodes on which to run your applications. And Ethereum was founded by a group of blockchain programmers, and they were actually Bitcoin programmers. And if you want more information, you can go out to the Ethereum website. And some private blockchains, Hyperledger Sawtooth, Hyperledger Fabric. It is hosted by the Linux Foundation. You can go out and look at the hyperledger.org projects. Some of the contributors are IBM, Accenture, Airbus, American Express, JP Morgan, but there are many others. IBM does tend to be a large contributor and a very vocal contributor, but it is not an IBM product. It is open source and hosted by the Linux Foundation. Multi-chain is a popular, it's based actually on Bitcoin. It's, I guess you could say it's a second generation version of Bitcoin that you can install on your own, and you can get more information at multichain.com. So either Corda can either be a private blockchain or it can be a permission blockchain. It's Corda, the vendor is R3, and you can go to corda.net and get more information, and Ripple as well, permission blockchain. And if you take a look here, you can see this in this matrix, we can actually see get some information about Ethereum, what's the industry focus, who governs it. Obviously, you can see, is it permissionless or permissioned, items such as that. Kind of a useful matrix here. A little bit about, so if you want to go out and try some hashing, you can go out and try it. Here is one website that hosts a hashing application or app. And what you would do is you just simply go out here, and there are many of these. You can just search. This is just one example. You can go in, you can input a string, click the hash, and you can see the output of the hash. So you can get an idea about any small change, and you can see how the hash changes. So any small, well, obviously with just a single digit entry here, anytime you change it, that obviously would be a big change. But if you can put in several characters here, make a small change in that, you would see how much the hash changes. So take a look at that. So in this lesson, we discussed the hashing functions and the hashes and how they enable the blockchain, and the hashes and the structure of the blockchain, introduction to different needs of public blockchains and the needs of the business enterprise, and introduction to some blockchain products like Ethereum, Hyperledger, Corda, and so on. Please complete the assessment. The answers are in the previous lesson we just completed. And again, for more resources, please check your learning materials. And if you're interested in more training, please also consult your learning materials. Next, we'll talk about blockchain operation and mining. And thank you. Welcome to this lesson, Introduction to Blockchain, presented by Coding Bootcamps. In this lesson, we're going to talk about the operation of a blockchain and mining on a blockchain. And this is just a little more about the instructor. We have covered this information. So what we learned so far is a bit of the history of a blockchain and the overall architecture. We also talked about some Bitcoin and give an introduction to the blockchain types, public and private blockchains. And we talked about hashes on the blockchain. So now let's take a look at some of the blockchain operations and mining procedures. So once data is entered into the blockchain, it is permanent. So that is one of the key reasons why blockchains are useful, is the entire blockchain is permanent and cannot be changed. Written data is hashed and cannot be changed. So we saw an example that hashes are very sensitive to changes. So maybe we should say that the hashes make the changes known or make them obvious. So if something does change, we can overwrite it with the correct information that before any type of change was attempted. And blockchain nodes must synchronize all together in order to come to consensus. Because the idea is that every node has the exact same data, and it wouldn't really be useful if there was different data on different nodes, because overall the entire network is supposed to have a single ledger. So, blockchain operating procedures and terms. So one term we're going to hear a little bit about is a term called a nonce. And a nonce is a number used in cryptography. And it's a number, it's never used, it's only ever used once. And a nonce is often a random number, and it can include a timestamp. And a nonce prevents repetition of patterns. So that's one of the one thing that the nonce does for us is it prevents any kind of repetition. So if anybody had thought that they could go in and cause difficulties on the blockchain by looking at patterns, the nonce is there to prevent any kind of patterns. And finding the block's nonce is a key requirement for adding a new block to the blockchain. So you can see here the client, and you can see the client request and server response. A nonce is requested, a nonce is then sent, and you can see here the username, the nonce, and the hash, and the nonce and password, and then a token is returned. So we can see here some of the ways that the nonce is actually used. So a Merkle tree is, actually the Merkle tree is discussed quite a bit in the white paper we saw from Satoshi Nakamoto about the blockchain. So our Merkle tree is essentially a tree structure of hashes. So it's hashes of hashes, essentially. Every leaf is labeled with the hash of a data block, and every non-leaf is labeled with the hash of the labels of its child nodes. So we'll take a look at this in a second, but Merkle trees are used for data verification, and they are also done for searching purposes. Merkle trees are very fast data structures, and data is transferred between computers in a peer-to-peer computer network, and Merkle trees are used for that data verification. So we can see here the actual Merkle tree. I guess it looks like a kind of an upside down tree, but here you can see what it was talking about here. These are the leaves here, so these are the data blocks, and then the non-leaves actually have the hashes on them. And you can see that these hashes are pointing back to previous blocks. So as the blocks go up, you can see their pointers. So they are hashes of hashes. And Merkle trees are also used for data compression on the blockchain. And let's talk a little bit about a block. So we introduced this a little earlier, but a block is a file. If you could ever navigate into the node where the blockchain is running, you could actually find the blocks are highly encrypted, but you could actually see the block files there. I wouldn't recommend trying it. But a block, again, is a file, usually limited to about 1 megabyte, and that, for the most part, is true across the board. Imagine there could be exceptions to that. But again, we can think of it as a block as a cell of a spreadsheet. So the overall spreadsheet could be the blockchain, and each cell could be a block, and data is written into the cell. It also includes things like timestamping, links back to the previous block. Block structure has 4 elements. So we have the block size, the header, and some other transaction information. So we can see here the description of block structure. So we can see here there are fields called the magic number, block size, the block header, and there's certain information in the block header, the transactions, and the transaction counts. So and one of the things that goes on while blocks are being validated is the miners are all checking for the correct block size, the number of transactions, the transactions themselves. We make sure that the block actually matches the expected structure. We just don't look at the transactions. And so some of the terms that you may hear, a block height is just simply the number of blocks. And I think we saw that on the Blockchain Explorer. We saw actual block height discussed, or maybe it talked about, I think it might have just said height. The block time is the time needed to generate the next block.
Thanks for watching. Feel free to add your questions as comments down below.
So forks, interestingly, we're going to see an example of a fork. There are temporary forks in a blockchain, and we'll see an example of that. But there's also something called a hard fork. A hard fork is when, in our blockchain community, if some of the community moves off and decides to go a different direction, they create what's called a hard fork, meaning we're going to take that last part of the blockchain that we all agree upon, and then we're going to make a full copy of that. And then we're going to use that as essentially a new blockchain, and we're going to move forward with the updating the application in a different way and adding data in a different way. And there are examples of hard forks. If you look for Bitcoin Cash, and there are some other examples, you can look up hard forks. It just means that there's been a split in the community. And a temporary fork is just simply we're all waiting. We all create kind of a temporary block on all the miners create a temporary block on their nodes, waiting to see if they are going to be the one selected to validate the transactions. And mining again. So there are lots of ways to define miners. Generally, miners are thought of as those that operate the nodes, those that keep the blockchain network updated and organized. And I agree with that definition. Miners verify and group transactions into a block. And miners also take part in the consensus algorithm to keep the ledger synchronized. So they will all vote on the transactions and validate that they are up to date. And then that one single new block is relayed to the entire blockchain, so everybody has the exact same data or the exact same copy of the ledger. And then when transacting and actually pending transactions are created. So we'll actually see this as transactions come in before they're validated, they are considered to be pending. And miners receive a notice of pending transactions and then begin to verify them. So verifying the transactions is essentially the work done to add a new block. So the miners verify the records, they add transactions to the block, and then as soon as all of the transactions are added, they begin to look for the new nonce for this new block. And then the hash will be added. So the miners use the computing processing power to find that nonce, and this is called the proof of work. So completing the proof of work essentially proves that the miner is contributing transaction, validating, and providing computing power and electricity to the blockchain network. At a certain interval, all processing on the blockchain stops, and this is done for broadcasting the new block across the network. And when 50% of the nodes agree, the nodes synchronize. So if I win the proof of work, I broadcast my validated transactions in my new block. If 50% of the miners agree, the new block is added. I receive an award, and then the whole process begins again. So a little bit more about mining. Locating the nonce while running the proof of work involves really no special skill set at all. Proof of work is the software uses a random number generation to simply test for the nonce. So it would be exactly similar to if you had a combination lock and trying different combinations until you opened it. That's exactly what's going on. So we can see here is our temporary fork. So as the proof of work is running, miners work to find the nonce for the blocks. So we can see here are our 3 permanent blocks in the blockchain, and we know there's going to be a block 4. So every node gets 4A, 4B, and so on. And so the miners begin to add and validate the pending transactions. And as soon as the proof of work is done, I can relay my information. If I win the proof of work, say I'm working on 4A, the 4A will just become the new block 4, and then all of these are just discarded. So for an exercise, what would happen if the ledgers of the nodes did not reach consensus? What would that look like? Think about that. Would that be useful? And a little summary. So our blockchain elements. So we had our nonce, our Merkle tree, our block data and terms. We talked about block height, block time, procedures, other terms. And please do go through this assessment. Again, true or false, and nonce is a random number. Add it to the block hash. True or false, a Merkle tree is not a way to search and compress data. So please take a look at the assessment. And just like we talked about before, the correct answers are in the previous lesson we just completed. And again, for additional resources, please consult your learning materials. And for additional training, please also consult your learning materials. And in our next session, we're going to talk about blockchain cryptography. Thank you. Welcome to this presentation of Introduction to Blockchain, presented by Coding Bootcamps. Blockchain cryptology. And a little bit about our instructor. So what we have done so far, we've looked at the overall architecture of blockchain. We've talked about Bitcoin. We've talked about the types of blockchain, whether it's private or public. We talked about hashing. We have talked about ledgers. So now we're going to talk about the cryptography or cryptology that blockchain uses. So a blockchain uses cryptology. So it uses a cryptology that we actually use quite often. Anytime we do any online shopping, we're actually using it. We're using a two-key encryption of our data to send a message back and forth to whoever we're transacting with. But let's first talk about blockchain is relatively simple in its architecture and how it works. Blockchain combines a set of technologies that have already existed, right? Ledgers and cryptology. So cryptology has been around for a long, long time too. Blockchain records and blockchain records an asset transaction by capturing owner, previous owner, the price, and timestamps. We looked at it. We saw a lot of other attributes, right, in our block headers, information that was captured. The blockchain also uses cryptology to encode any kind of messages that can only be performed or confirmed and read by certain intended parties. So ledgers have been used for centuries. We just talked quite a few lessons ago, quite a bit about it. And so it's really to record asset ownership and asset transfer. And cryptography has also been used for centuries. So cryptography is a mathematically way to encode a message in order to hide the message from adversaries and prevent them from knowing what the message says. So it's a way to it's a mathematical way to make sure that the message is read only by the intended party. And what happens is the intended one party has a way of encrypting the message, and the intended party has a way of decrypting the message. So a blockchain also uses cryptology. And so it uses, well, a strategy that secures the messages on the computer networks. And so today's cryptology techniques are a lot more complex than they were in the past. A blockchain uses a key pair encryption or asymmetric encryption to ensure that only the intended party can receive the messages. And we actually use asymmetric encryption or key pair encryption all of the time. Anytime you see HTTPS, that is secure HTTP, and you are actually exchanging keys with the person that, or with the entity of which you're transacting. So any kind of e-commerce is done using key pair encryption. So with key pair encryption, each user has a pair of keys. There's a private key and a public key. The keys are related as they're mathematically related as they were generated at the same time. And anytime, again, you go to a secure website, you're using key pair encryption. So we had an introduction to this a little earlier. So a public key is like our address. Everybody knows our public key. So our public key can be a translator of encrypted data if we send a message. If we send a message to someone else, they can translate that encryption. The public key is known to all members of the blockchain. Private key also is a digital signature, and the receiver of a message uses his or her private key to decrypt a message. So it all depends which key is used for encryption, which will determine which key can be used for decryption. So if I am sending Joe a message, I will use Joe's public key to encrypt it, and Joe will use his private key to decrypt it. That way I know I'm sending a message to Joe, and since Joe is the only one that has his private key, I know that he is the only one that can decrypt it. So if he reads it, I know it was Joe that read it. And so a blockchain uses cryptology. Again, messages are encrypted using the cryptographic functions. So a simple encryption function we have here would be blockchain training. So this could be a message. And a very simple cryptographic function shifts the position of a letter or character to the +1. So instead of a letter, everywhere I have a letter A, if I shift the position by 1, it would be, we know A is number 1 in the alphabet, and I add 1 to number 1, it's 2. So every time I mean to say A, I really say B. So that is my mathematical mathematical cipher, and we see here blockchain training. If I want to encrypt it using this same approach here, this is what it would look like. And then since I'm the only one that knows how to decipher this, I could decipher it back to blockchain training. So presuming the message receiver has the key, so that's it. You need to have the key. And this type of approach has been used for centuries. The Roman Empire used to encrypt and decrypt their messages just to validate that within the armies, the correct person only the intended party would be able to read the message. So again, if I wanted to encrypt the message hi, I would again take H and I, and I'd shift them 1 letter. And if I shifted H 1 position, it would be I, and if I shifted I 1 position, it would be J. So again, we see here what it would look like. So with cryptology for a blockchain, it's a little more complex. So we see here Kelly's public key is known to the community, and then Tom uses Kelly's public key to encrypt the message. So Tom writes a message here, hi Kelly, and encrypts it using Kelly's public key, which we all know, and here is the result. And the only one that should be able to decrypt it would be Kelly. So Kelly takes her private key and decrypts the message and then is able to read it exactly how it was written. And only Kelly has her private key. The message comes back to Tom. And I guess you could say it's...
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
It's almost like a signature as well. It allows Tom to know that he is truly interacting with Kelly. And that's why we say that the private key is a digital signature. It verifies the intended person read the message and validates the message was not changed. So it is also a proof of identity. And a little bit about the terminology, right? We have our secret, or I guess you could say the message that we want only to be read by the intended party. The key is the mathematical mathematical data that codes and decodes the message. A function is a short computer program to encode the secret message, and then the cipher is the result of that function. So that encrypted message is the cipher. And we see our digital wallets actually use our private and public keys for us. Inside of our digital wallets, we keep our keys. And we can see here, well, this is just hidden from us here, but this would be our public key here. And then scanning this, we're able to complete. So if I scan somebody else's using my app, I would be able to get their I would be able to use the keys to encrypt and decrypt the messages, and then we would be able to carry on the transactions. So for this exercise, go in there and decipher the secret message here. And again, the key here is the character position again, -1. See what that is. It has not changed. At least the strategy has not changed. And again here, what we looked at are blockchain's use of cryptology, the single and double key based cryptology, and the operation of double key based cryptology. And we talked about some terminology. Please also take a look at the assessment. And more resources, so for further information, please consult your learning materials. And if you need more training, please also consult your learning materials. And in our next session, we're going to discuss blockchain consensus. Thank you. Welcome to this lesson of Introduction to Blockchain presented by Coding Bootcamps. This is blockchain consensus. We've covered information about your instructor and what we have learned so far. Well, in the previous lesson, we covered cryptography. Before that, we talked about hashes, types of blockchains, private, public. We've talked about blocks and how they're constructed. So now we're going to take a deep dive into blockchain consensus. So consensus and the truth of the blockchain. You'll often hear the consensus referred to as the truth, interestingly enough. And so consensus is necessary because there are multiple nodes. The idea that these nodes all contain the same ledger. So the ledger, it's supposed to be one ledger, many nodes. So the ledger is actually running on different computers, which means the ledger configuration, the data, however you want to discuss it or indicate it, can drift a little bit. So there may be times where the ledgers do not agree, and they have to agree. So blockchains have consensus algorithms that bring all the ledgers on all the nodes into synchronization. so that all the copies of the ledger are identical again. So quite often this is referred to, like I said, as the truth. So we have proof of work, and that is, I agree, is a very mature, or the most mature consensus algorithm. I do agree with that. And so whoever wins a proof of work, whoever is able to solve that puzzle, is able to then broadcast his or her validated transactions of a single block. So let's remember that blockchains are built one block at a time. So if I win the proof of work, I'm only sending the most recent transactions to the other nodes. So it's just one block, and that is our new version of the truth. And proof of work, again, is what Bitcoin uses. However, other consensus algorithms are beginning to quickly emerge. So with proof of work, it's an economic measure it was started off as a way to deter denial of service attacks and service abuses such as spam by requiring work to be done of a service requester, usually meaning processing time by a computer. The idea was you have to really want to send out whatever you need to send out in order that you would complete this work. A key feature of this schemes is their asymmetry. Right? The work must be moderately hard on the requester side, but easy to check for the service provider. And so the idea, also known as the CPU cost function, client puzzle, computational puzzle, or CPU pricing functions. Either way, the proof of work consumes a lot of energy, and it's very expensive and quite time consuming. So with proof of work, you can almost think of it as a CAPTCHA for a computer. If you're familiar with CAPTCHAs, a CAPTCHA is intended for a human to solve quickly rather than a computer. When a block is full, each node competes to solve that guessing game, which is the proof of work. So we talked about that earlier. So they're competing to find the nonce. So they're running random combinations in order to find that nonce, in order to create that hash for the block that everyone has just been validating. So the miners have all been validating the transactions, and now they want to hash that block. So a miner will answer the relays. So once a miner actually has that block, he or she relays that new block to the rest of the network, and all the miners confirm the solution by trying their nonce on their own blocks. And if 51% of the miners agree, the block is added. Well, that happens to be how it is with blockchain. It does not have other blockchains can certainly have other rules, but 51% happens to be Bitcoins, what the Bitcoin community is currently using. There's also proof of stake consensus. So that's another consensus algorithm. It's definitely an alternative to proof of work. With proof of stake, you don't run random numbers until the number is found. So it's considered much more green, consumes a lot less electricity, a lot less energy. And the proof of stake, the miners all bet a small amount of their existing cryptocurrency for that blockchain. And the miners that bet and honestly follow the rules can win back their bet. When I say honestly follow the rules, meaning they are valid in validating the transactions. So they're honest in validating the transactions. The miners can keep betting, and if they follow the rules, they will win back their bets. Any kind of rule breakers will lose their bets. So the action here, a block is filled, and at the time of the group consensus, all who wish to participate in the group consensus essentially stake or bet their funds. And a player is selected at random. So out of maybe 25 of us, one person gets to reveal his or her block with the validated transactions. The player's block is revealed to the other players. And if the majority of players differ with the block data, the player loses. and loses the amount of cryptocurrency he or she put up. So the stake is lost. So it certainly pays to be honest. Ethereum is moving to proof of stake, and proof of stake is promising as, again, it is a reliable consensus algorithm and is much less expensive. So with proof of work versus proof of stake, again, there is no processing during consensus. There is a criticism that proof of stake, well, could be centralization. Proof of work is not at all centralization. I guess that argument will continue to go on, and then we will see where it takes us. Proof of stake is still new, whereas proof of work is very mature. And then some other blockchain consensus algorithms. There's the proof of activity. It's a combination of proof of work and proof of stake, where blocks are mined and confirmed with proof of stake. There's also proof of burn. So proof of burn involves sending coins to what's called a dead address. So a dead public key, and then blocks are mined and confirmed with proof of stake, and then the coins burned. The more coins burned, the better chances of being selected to be the next one to mine the next block and win the reward. Proof of space, which is getting some attention. Proof of space proposes we apply the same principles as proof of stake by allocating a dedicated amount of memory or disk instead of CPU time. And if you allocate more space, the better your chances are of mining the next block. And proof of elapsed time, similar to proof of work, but it runs on a custom, more efficient environment. So consensus is very important for the operation of the blockchain, particularly where there's only one ledger and all nodes are equal. Consensus is obviously important no matter what. There are blockchains where all nodes are not the same, where there are different nodes. Hyperledger Fabric and also Corda, there are specialty nodes there, but we don't have that with Bitcoin. So it is critical on a Bitcoin or Ethereum network. Ethereum, all node, there's just one node type on Ethereum too. It's critical that the ledgers always agree, so the community needs some kind of a consensus. So we discussed again, in summary, our proof of work consensus. Proof of work is solving a very difficult mathematical puzzle. The important things to take away from here are definitely proof of work and proof of stake. The other algorithms are important, but proof of work is obviously what's used, is very popular right now, and it is in use. And proof of stake, it seems to be the consensus algorithms that a lot of blockchains are moving toward. And again, let's look at our assessment. And also for additional resources, consult your learning materials. And if you're interested in more training, also consult your learning materials. And in our next session, we'll talk about distributed networks. So thank you. Welcome to this presentation of Introduction to Blockchain Technology. Again, this is a presentation of coding bootcamps. Distributed blockchain networks. And this is information about our instructor, which we have covered. So what we have discussed so far are consensus algorithms. We discussed hashing. We discussed mining, blockchain mining. We discussed Bitcoin. We also discussed the blockchain and the blocks and how blocks are filled with transactions. So right now we are going to talk about the the blockchain distributed network. So every blockchain network is distributed in some way. You may have heard the term distributed ledger technologies. And that's an updated name for blockchains, distributed ledger technologies, because there are some blockchains.
Thanks for watching. Please like and share this video
Out there, particularly Hyperledger and Corda, that are not constructed in the same way that like a Bitcoin network is constructed. In Bitcoin, there's just one type of node. In Hyperledger Fabric and in Corda, there are specialty nodes that perform specialty jobs. However, though, the ledger always needs to be the same. So every blockchain network has some level of distribution. You could say that besides being a ledger, a blockchain is a supercomputer. So it's the sum total of all the processing power of all the nodes. And that's been talked about. We've heard the term, especially for Ethereum, of an operating network instead of an operating system, that we are a term that we're all familiar with and all comfortable with. So applications run on the operating network much in the same way that applications would run on your desktop or laptop on that operating system. Blockchain, again, is community-based. Nobody owns it. There is no central authority. And all nodes on most networks are equal peers. Blockchains all run, no matter what they are, on a distributed network. And if we think about the original networks, so when networks were first assembled, all the networks were centralized. So when we say centralized, the network, they had a focal point in which all of the nodes communicated. And every node communicated with that focal point, and then messages were relayed from the central focal point to the receiver node. So it was always to the central node or central focal point back to the intended node for the message. The central node was the weak link in a centralized network, because if that went offline, the whole network went down. The blockchain runs, again, on a distributed network, and you can see here what a centralized network looks like. So there is this central focal point, and all of the nodes here on the network communicate through that central focal point. So these types of networks, as you can imagine, are very vulnerable to attack, because the only point you can bring down the whole network by just attacking the focal point, the central focal point. Blockchains, again, use decentralized, meaning that the networks or decentralized networks also make use of the focal point, but there are many focal points. So it's almost like a network of centralized networks. The nodes that connect to the focal point are called leaves, and the leaves have a primary focal point, but they can also move back toward a different focal point. So the leaves send their messages to their own focal point nodes, and then they also send the messages over to the appropriate receiving focal point node. And again, decentralized networks have more redundancy, so they are more difficult to attack. Decentralized networks do have central authorities, and even though they're less vulnerable, they are still vulnerable to attack. So we can see here with a decentralized network, we have several focal points. So if any of these focal points, any one of them would go offline, we would have other focal points that come back on. And if this node needed to communicate with this node, it would be relayed through their focal points. So again, they could have multiple authorities. So they They're not distributed networks, as they do have this concept of the focal point. And fully distributed networks have no central focal points or central authorities. Each node or computer on a distributed network communicates directly with the others in a peer-to-peer format. And since there are no central nodes, a distributed network is the least vulnerable to attack. So, because if any node goes offline in a distributed network, another one can be just brought back on to take its place. So distributed networks are considered to be the most resilient, and there are no single points of failure. And again, they are less vulnerable to attack. So here we see a distributed network here. There are no focal points. Every node is a peer. So if any one of these goes offline, another node can step up to take its place. And there are no central authorities on a distributed network. And with the blockchain running on the distributed network, the new transactions and blocks are broadcast across the network and using something called a gossip protocol. So essentially, the nodes, the messages just move through one node to another or several to another. And with no central authority, all the nodes will have to synchronize the ledger. So we need some way to come to consensus again. We've already talked about consensus, and resynchronize periodically. Each ledger on each node will return the same data when queried. So that's important, because even on a network that has this level of complexity, there is still supposed to only be one ledger. So that's why we say that each node will return the same data. And again, centralized architecture would not be able to handle the transactions anyway close to what a distributed network can handle it for the blockchain. If a centralized database were attacked, account holders would have a chance to lose whatever cryptocurrency they are attempting to transact. So that distributed ledger is many copies of the ledger, so fraud is less likely to succeed. So if we take a look on here again, if a hacker attempted to attack just one of the nodes, it would get taken offline and then get replaced with the correct copy of the ledger. So again, our blockchain is hashed, and then it's stored on a distributed network, so it's much, much less vulnerable to attack. You hear the term sometimes unhackable, and I'll leave that up to everyone really to decide whether this is really unhackable. It is more apparent, hack apparent, so then steps can be taken to quickly repair any kind of damage that a hack has caused. So again, public blockchains are not owned by anyone, and blockchain is a distributed ledger that runs on a peer-to-peer network. The centralized network has a single focal node. Decentralized networks have several focal points, and distributed networks are completely peer-to-peer, have no central focal points. Please review the assessment. And again, for more information, please consult your learning materials. And if you're interested in more training, again, please consult your learning materials. And next, we'll review how a blockchain differs from a database. So they are both repositories of data. Blockchain's a repository of data, and a database is a repository of data. But the way they manage data and the way they process data is quite different. Again, thank you. Welcome to this presentation of Introduction to Blockchain Technology from Coding Bootcamps. Blockchain versus a database, how a blockchain differs from a database. And this is material that we've covered. So far, we have looked at blockchain networks. We just concluded a session on blockchain networks, how blockchains run on distributed networks. We've also looked at the consensus algorithms, mining, the nature of the blockchain blocks. We looked at hashes. We looked at a introduction to blockchain and applications such as Bitcoin. And we looked at private and public blockchains. So now we're going to look at something that comes up quite often is blockchain versus a database. How do they differ, and how are they similar? Well, like a database, blockchain is a repository of data. So that's absolutely true. So based on that, they have a lot in common. But they are still quite different. A blockchain is not a traditional database where records are organized in, I guess, by type, or we could think of a relational database where we have we actually model the data or model the organization, and that lets us know what data we need. A blockchain doesn't work that way at all. So a traditional database is obviously highly centralized, where records are added to the database. They're read by applications, by users. They're updated by applications and by users. And yes, they can be deleted by users and by applications. So a traditional database follows, I guess you could say, this format of CRUD, create, read, update, and delete. And a blockchain is a ledger. So the same way data is recorded in a ledger is the same way that it's recorded in a blockchain. And also, it's managed the same way. So just like a ledger, records are only added to a blockchain. So it is append only. Blockchain does not use CRUD. So no existing records are ever modified or deleted. So if a value needs to be changed, a new entry is added to the ledger as the transaction values are updated. So if we want to change a balance, we just don't go into that record with a balance. We add a new transaction in order to change that balance. So we see here this record, Pete and how much he has, $90, and we see here Ralph has had $14.25. But if we want to, if Ralph used some of that, what we would do is we would subtract 10. So we'd add a new record where we subtract 10, and then Ralph's new balance is here. So we would track it that way. So a database would obviously would manage that data much differently from how a ledger or a blockchain would manage it. So there are specific advantages between the two for specific purposes. Again, a blockchain is resilient, meaning it has many nodes, and if any of those nodes go offline, there'll be another node to take its place. Blockchain is immutable, unlike a database where we just said, right, create, read, update, and delete. So obviously a database can be changed. Database is also central, so it is vulnerable to attack. It is asset transaction focused, and so also it's inexpensive for clearing costs for a blockchain, and a blockchain supports anonymity if needed. A blockchain is a solution for the following conditions. So there may be times where your application will benefit from a blockchain. There may be times where a central database is all you need. So a few things to consider. If you think you may need a blockchain, do you need public transparency? Do you need anonymity? How about what's the degree of fault tolerance that you need? Does this application need to always be up?
Thanks for watching. Feel free to add your questions as comments down below.
Is there a high degree of transaction demand? Prevention of double transactions of the same asset. So these are things you want to think about. Do you want a trustless environment? Low transaction fees, less vulnerability to attack. These are all, and we've talked about most of these are all advantages that a blockchain would bring. Centralized databases are certainly less complex to maintain and typically are able to complete more transactions per minute. And so they tend to be faster, although that is changing. Simple to integrate into an overall solution. There's obviously that central databases are the most popular types of applications. So there is a lot of experience. So the community has a lot of experience with them. There's a lot of resources. Trust is irrelevant with a centralized database. And so you can evaluate these and decide which direction you need to go. And should we pick a blockchain because it's new and exciting technology? Well, typically the answer to that was no. Pick the right solution for what you need, right? So the right solution for your needs. Perform real analysis on your business problem and make the right decision. Because once you pick a direction, there really is no going back once your application is built. So in summary here, some of the things that we discussed is our centralized databases and how they permit us to create, read, update, and delete data. Distributed ledgers and only allow us to append new records. And centralized databases can be built for a business solution. Blockchain solves some very specific problems. So, and we also talked about when a blockchain solution may be most appropriate. So please take a look at the assessment. And for additional resources, if you're interested in additional training, and in our next session, we're going to talk about first and second generation blockchains. So again, thank you. Welcome to this Introduction to Blockchain Technology, presented by Coding Bootcamps. In this presentation, we're going to discuss first and second generation blockchains. So we've already covered this information. And so far, what we have covered is our blockchain networks. We are the way that blockchains are mined, the way that hashes work. So we also talked about proof of work and consensus. So now we're going to move on to first and second generation blockchains. So our first generation blockchains track ownership of their native tokens. So something like a Bitcoin, perfect example. Bitcoin only manages its native token and the transactions associated with it. That's it. So Bitcoin is, again, a great example of a first generation blockchain. There are no other assets on the Bitcoin application. Everything is managed. Anything that's managed is just for Bitcoin. First generation blockchains are not bad or obsolete. Blockchains have progressed to a point where now we have second generation blockchains. That is certainly more advanced. Shortly after the success of Bitcoin, different communities began to build blockchains. And of course, all these communities envisioned that there was much more that you could do with our blockchain networks. And the communities divide ways for blockchains to manage other assets besides native tokens, and also to run applications. And this is where the idea of the smart contract comes from. A smart contract is computer code, or is essentially an application that you're running on the blockchain. It can execute the terms of an actual contract, but in reality, it has very little to do with a contract in that, other than that, it can enforce or carry out the terms of a legal contract. Smart contracts could reach their full level of usefulness on a blockchain because there are these ways to make payments. So the difficulties associated with making payments were eliminated by the blockchain. And the idea was first theorized long before the popularity of blockchains. The invention of the blockchain provided an ideal environment for running of smart contracts. On the blockchain, smart contracts can enforce the rules of the legal agreements and make payments to the interested parties. Again, the name sounds deceiving, but smart contracts are exactly computer programs or applications that run on a blockchain. Smart contracts are immutable once they are deployed. Now, there have been some advances in blockchain where smart contracts may run slightly differently on Hyperledger. So we can actually update smart contracts in an easier way than they're done on most other blockchain platforms. And smart contracts can be virtual versions of written contracts, just like we said. They can contain rules that, when satisfied, can release payments. Sometimes this is known as the escrow model. When certain conditions are satisfied, payments can be made from one user's wallet to another user's wallet. You could say that, I've actually heard this comparison before, smart contracts are like vending machines. You put your payment in, you make your selection, and whatever you selected is dispensed. And here we can just take a look at a basic transaction with a smart contract. So this right here is how a typical contract functions now. There's some kind of an agreement. A contract is in written form. There's some kind of a third party, a court or implied third party, and then there's execution. Or this could be a title company, a court, several different entities could be a third party. But with smart contracts, there's no need for the third party. So there can be an agreement. Smart contract can be written, and then it can execute. So here, parties can work with a smart contract peer-to-peer, sell assets such as homes or automobiles. So smart contracts can function as multi-signature accounts, and they can enforce the rules again to require that payments are made. They can run autonomously. They provide trust and reliability and also backup. They can reduce transaction time as well, and then store information about the assets, such as, and an asset can be a domain registration, they can be information, it can be hard assets, it can be any type of. So if we look here for the modeling for a distributed application. So a distributed application is a smart contract running on a blockchain but it is running in a distributed manner. So it's running on the network, on the operating network. So it's distributed on all of the nodes. First, we have the logic development. Then we have, in this case, it's Ethereum. EVM is Ethereum virtual machine, compiles the code. Then there is private and public key management, and then there's an update of the Ethereum ledger. Again, here is another example of a distributed application with a smart contract. In this case, this again is the escrow model. So here, Sandy needs an outdoor light installed. She hires Sam and they agree to use a smart contract. Sam completes the tasks, then the smart contract will pay him. So Sandy uploads her Ether to the escrow. And then as certain conditions are met, Sam can get paid. So after Sam runs the wire, he gets some kind of a payment. And then ultimately he installs the light and payment in full is completed. To develop a smart contract or any kind of distributed application, you need some kind of a development environment. Remix is a quite impressive development environment for Ethereum. So Remix is a browser-based IDE for Ethereum smart contract development. Since it's browser-based, there is no installation, and Remix executes typically on what is called a JavaScript environment that simulates an Ethereum blockchain. You also can use what's called a W3 or a Web3 provider, and Remix is, like I said, quite an impressive editor, and it provides the syntax highlighting, compiling, deployment, and visual debugging. So when you navigate to the URL, you can see the Remix development environment and its various what they call modules or views. We have our editor here, which you can see the syntax highlighting. And one thing about second generation blockchain smart contracts are assets can be built that model real world objects. So attributes that model these real world objects can be built in. So in this case, we can set up a clock asset. You can give it an item number, a color, a type, and these assets are transacted on the blockchain in the same way the blockchain's native token would be transacted. So we can see here is actual code that would describe a customer. Now it's up to us. Here we can see the customer's first name, last name, email, and their Ethereum wallet address. And we can see a function that will pay that customer, or maybe the customer will pay us. And we can define how we actually manage that customer. So here, the status of a customer, we can see here. We can build up customers in what we call a data structure here. And the payments will be made again as job status is completed. So there is a way to mark something as complete. If you look closely there, you can see job status as complete again, and then we can run through and we can see here there's a payee and a receiver for our smart contracts. And we can see here that there are ways to update certain status so we can decide if certain conditions are being met. And there's ways to pass this back to this smart contract. The nature of blockchains may not make it attractive for businesses. However, the public, when a blockchain is public, maybe a little bit less attractive for business, let's say. But many blockchains have a single ledger. However, a second generation blockchains can be multi-ledger. So Hyperledger Fabric is one such product that has multiple ledgers. And we already talked about private and permissions blockchains such as Corda and Ripple. And these new blockchain solutions remove the public permissionless aspects. So here we talked about first generation blockchains, second generation blockchains. I just want to quickly go into show a demo of a smart contract. So here we have our smart contract. This is called inventory list. And we have an item right here that we call item, and we're giving the item attributes. So in this case, we give it an item ID, we give it some kind of content like a name, you can see that here, and then whether it's present in inventory or not. And
if you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
That'll be true or false. And you could see here that we begin, as items come in, we can add items to our inventory list, and we can mark them as present in inventory or not. And that's what this is doing here. So what we'll do is we'll compile it. So this is using Remix. Click our compile module here, click the compile button, and that compiled. That's great. And then we'll go to our deployment module. And this is where we are running in what's called a JavaScript virtual environment, where we have a simulated Ethereum node. And here are all of our addresses. So you can see here are all of the addresses, and they're truncated, but they also have some test ether associated with them. And so here we only have one contract in the whole file. That's fine. Click the deploy button. And from this list, we can see here we can create an item. Well, suppose I want to sell an item called iPad, or iPad 2, or iPad Pro. Let's make it iPad Pro. And you got everything there. iPad Pro. And so let's create the item. And so now that's been assigned an item count. Let's click on item count, and we see we have 11 in here. Let's see what our number 11 is. It should be our iPad Pro. Let's click items. And there it is, iPad Pro. So that was assigned the ID of 11. Now, how can I say whether it's in inventory or not? Well, I do this toggle present. Because right now, notice the status is false. So we don't have it in inventory. Maybe we're expecting it to get it. We don't have it in yet. But we know it's ID 11. So let's put that in there and let's toggle it. And let's click on here, items. Now notice it's true. So now we have that item in inventory. If you think about it, what else can we add to this smart contract? Maybe the actual number we have in stock. Maybe that would be something else worthwhile having. So please, please look over the assessment. And again, if you need additional resources, please consult your learning materials. And if you need more training, again, please consult your training materials. Next session, we'll talk about popular blockchains. Thank you. Welcome to this presentation of Introduction to Blockchain Technology, presented by Coding Bootcamps. Popular blockchains. And please review this material. So far we've talked about smart contracts, we have talked about hashing, we have talked about the blockchain network, we have discussed mining, we have discussed the Bitcoin and other blockchain applications. We discussed Ethereum, we discussed Corda, and now we're going to go into some more detail on other popular blockchains. So Ethereum is a very popular second generation blockchain. Ethereum is considered an operating network And we introduced that term in some previous lessons. Just to review, similar to an operating system where you can have 1, 2, 3, 4, many applications running, all sharing resources from the operating system. On Ethereum is an operating network. So you can run distributed applications on Ethereum, and the distributed applications run on the operating network and use the resources of the operating network, all of the nodes that make up the Ethereum blockchain. Ethereum was built by Bitcoin developers. They had a vision that they wanted to do more than what just Bitcoin did, so they built Ethereum. They actually sold Bitcoin to raise the money to build Ethereum. And the applications that run on the Ethereum network are called distributed applications, or dApps. This is the Ethereum website. Ethereum, like Bitcoin, is a single ledger. All nodes are identical. Ethereum has a native token. It's called Ether. And you must pay a certain amount of Ether to actually run your applications on Ethereum. Ethereum is getting faster with its the amount of transactions that can be processed, and the Ethereum currency is used to complete transactions on the Ethereum network. And if we take a look here, we can actually see Etherscan.io, also another blockchain explorer. This is for Ethereum, and you can go on Etherscan.io. We can see the from and to address. We can see the timestamps. You can see the transaction hash. You can see the contract input, output. You can see how much. In this case, no Ether was actually sent to either party, so this contract actually did something. And Ethereum was founded by a Bitcoin developer by the name of Vitalik Buterin, and it went live in 2015. Ethereum is a public blockchain based on again, the distributed computing platform. And Ethereum also includes the Ethereum virtual machine, or EVM. And you can create smart contracts. There are Ethereum wallets, the same as Bitcoin. And the applications that run, smart contract applications that run on Ethereum, are called distributed applications. And you can build web applications for Ethereum. The Ethereum virtual machine is a development and runtime for applications that run on the Ethereum network. EVM is designed to be development language neutral. So the idea behind Ethereum is you don't have to know one single language. You can know many, and then that language can compile. Using the EVM can compile into bytecode. So you can know Solidity, Viper, C++, Java, Python, JavaScript, C#, or more. It compiles using the EVM to the Ethereum bytecode. So so this is very similar to Java or .NET. So you write in your programming language of choice, you compile on the Ethereum virtual machine, and then this smart contract or distributed application runs on the Ethereum network. Some other popular blockchains, Hyperledger Fabric. So again, here's this distributed ledger technology and smart contract engine. So Hyperledger Fabric, not all the nodes are the same. And then when you start having slightly different nodes, you begin to drift more to this distributed ledger technology. Hyperledger is also a multi-ledger. So you can have several ledgers. You don't have just one. Hyperledger Fabric is an enterprise-grade, permissioned, distributed ledger framework for developing applications. And Hyperledger Fabric is a private blockchain. It's permissioned. It preserves privacy. It was discussed earlier that the attributes and properties of a public permissionless blockchain would not be desirable for business enterprises, and that's true. Public blockchains are best fit for Financial services, insurance, or other industries require a high degree of customer privacy. So public blockchains are not a great fit for healthcare, financial services, insurance, or other industries that have high degrees of customer privacy or are regulated. Hyperledger's goal is to build the benefits of the blockchain into a enterprise-worthy blockchain. And again, for just to recap some of the attributes of a private blockchain, we still have the distributed ledger. Data is permission, so only those that need to see the data on a private blockchain. Permissioned roles can manage any type of asset, so not just the native token. The ledger is available to those who need to see it. There's still this concept of immutability. However, there are known users. Visibility is based on role. There are fewer nodes with known users and smart contracts. And Hyperledger Fabric, data sharing and data privacy. So that's all built into Fabric. Having known users with anonymity is not an option on a private blockchain. Controlling visibility and allowing users to control their data. That is what business needs. And there is some limited consensus. It's not that important at this point when you're on a relatively small network that is that is used between just a handful of parties like Hyperledger is designed. Consensus becomes it's not the same as it is if you have a single ledger running on dozens, if not hundreds of nodes. So here, consensus is really up to the transactors. Once the transactors sign the transactions, the consensus is reached. And just like we've been talking about here, Hyperledger is in fact multi-ledger blockchain. So Ethereum, Bitcoin, they are single ledgers. The multiple hyperledgers are called channels. So you might hear that term when talking about Hyperledger. You'll hear channels that allow two or more users to conduct transactions in private. And you may hear transaction or smart contracts referred to as chain code, usually written either in JavaScript or in the Go language. Corda is another popular private blockchain. It's more of a consortium private blockchain. And what business users will do is stand up a Corda node in, say, their office or in a department. And then they have access to the Corda ledger. And just like Hyperledger, Corda is a permission blockchain. And Corda was developed to allow transactors to directly update the Corda ledger. So here, the big savings here is the users update the ledger on their own. Corda has a rich API and smart contract engine. It's fully built on the Java virtual machine. Corda applications are called Corda apps, and they are written in Java. And Corda was initially developed for the financial services industry or other regulated industries, though since that time, Corda has added under other industries. Corda manages financial instruments, assets such as bonds, securities, or cash, and Corda has branched out to other types of asset management to the fact where it can do any type of asset. Corda does not have a native token, and Corda recently expanded support to all industries or any type of asset. So we can see here just updating of the ledger. So we can see here an action takes place and it goes through these steps in the Corda ledger between, well, in this case, these are the two transactors. And we can see here the Corda transaction here with the, in this case, it was a loan to the bank. And we can see here that cash was used to pay the loan. And there were attachments associated with it. And then there were, this is how consensus is reached. There are signatures, cryptographic signatures. The Corda network is not a gossip network. only the nodes involved in the transaction communicate. So unlike a lot of other blockchains like Ethereum, like blockchain, where all nodes are, where the transactions are broadcast to all nodes, Corda, it's just the nodes that need to be part of the transaction. So it is not a global broadcast or gossip network. It's peer-to-peer only, and peers communicate using a protocol similar to the way email works, and messages are sent between nodes. So Corda, not all nodes are the same. They're just like with Hyperledger, there are different types of nodes.
Thanks for watching. Please like and share this video.
On a Corda network. Some other popular blockchains, EOS, and keep your eye on this one. EOS is growing strong. The vendor is Block 1, so look for Block 1. There's also the Stellar Network, Hyperledger Sawtooth, OpenChain, Neo, and Ripple. So for the exercise here, let's go out to a blockchain explorer and view some of the transactions. And also, you can go to Etherscan and view some Ethereum transaction as well, and then find another blockchain explorer. In summary here, we talked about the Ethereum blockchain, Ethereum virtual machine, Hyperledger and Hyperledger Fabric and Hyperledger Sawtooth, Corda, and other blockchains. Please look through the assessment and additional resources. Please consult your training materials. And in case you need additional training. And in the next session, we're going to talk about cryptocurrencies and blockchain. Thank you. Welcome to this lesson, Introduction to Blockchain, presented by Coding Bootcamps. The importance of cryptocurrencies on blockchains. Just review this information. This is a recap of the information about our instructor. And so far, we have looked at popular blockchains. We have looked at building smart contracts and building distributed applications, the types of blockchains, private and public. We've looked at mining, and we've looked at hashes, and we've looked at ledgers and the structure of a blockchain. So now we're going to talk about cryptocurrencies particularly. So we know that money is an instrument for trade. And as our society has advanced, technology has also advanced. And with any kind of advancement, we know trade also has become more complex. As trade became more complex, transactions also became more complex and required a trusted third party. We were doing business with somebody we didn't know. So we needed a third party to validate that the transactors did indeed have the money for the transaction, and the transaction gets completed, and or both parties get paid. And the third party always gets a payment as well. If payments needed to be made, the steps are quite similar no matter who the trusted third party is. So whether we have a bank or whether we have a title company or somebody like a PayPal, the steps are usually the same, validating the both accounts are valid and updating the ledgers. And we can see here that if we wanted to make a payment of $500 to a store for an item, the trusted third party would complete, in general, these steps. Would validate that the payer or the purchaser does indeed have at least $500 in his or her account, and then would debit the ledger for the purchaser minus $500, and then through the banking system, an entry of plus $500 is eventually made to the store's account. And that's a very, very general explanation. In the example, no account holder ever took possession of the money. There was no physical possession. The money never moved only ledger updates were completed. The steps in this example obviously involve work, time, effort, value-added services. And these services are costly. A fee can be charged for these services. And many times transaction fees can be quite high. Cryptocurrencies are a different form of money. So there is no reason why ledger entries performed by a bank or a trusted third party cannot be performed directly by the transactors. That is the basis for a lot of payment networks or payment blockchains. There's no reason why the ledger updates could not be performed using an application over the internet. This type of model would be far less expensive if the transactors themselves updated the ledgers directly. So cryptocurrencies can facilitate direct update of ledgers, therefore can facilitate these types of transactions completely independent and under no one else's control. Cryptocurrencies make it possible for populations, for all populations to participate in transactions. If we think about, say, a certain unbanked, what they call sometimes unbanked populations where banking services are not available, cryptocurrencies and blockchains makes a great solution because these participants can participate in transactions, usually of very small quantities or microtransactions. Often microtransactions were considered to be too expensive because of fees, but cryptocurrencies and blockchains make microtransactions available. And this particularly is a great use case for unbanked populations and a way to deliver commerce to the unbanked populations. And blockchain is based on, again, existing technologies, ledgers, cryptology, networking. Blockchain is disruptive and innovative, so often the definition of innovation is disruption. And many blockchain projects have already been launched. Dozens and dozens, if not hundreds, of blockchain applications are now available. Blockchains not only provide cryptocurrency transactions, but can also provide tokenization. Tokenization is the idea of something of value is modeled in a token for trade on a blockchain. So I could buy a property, say it's worth $100,000, and then I can tokenize that property or the value of that property into, say, 1,000 tokens, and then I can sell those 1,000 tokens for $100 each. And if you want to own 2% of my property, you can pay me $200. Any increase in value to that property would be an increase in the value of your tokens. So they would be a very special cryptocurrency, we would just call them tokens. An asset of any item or any value can be tokenized and supported on a blockchain. The digital asset is anything that exists in binary format and can come with any kind of use. So some other examples of items that can be tokenized are video files, audio files, financial instruments such as stocks, bonds, even currencies, even fiat currencies, records like certificates, ownerships, education, deeds can be, deeds to homes. So we can, birth certificates, marriage licenses, all can reside on the blockchain and be tokenized. Asset tokenization can make ownership registration more efficient to many, many more populations, if not all populations. It can also make the concept of ownership registration available to populations where formal registration never existed. So there are many places in the world where marriages are not registered, where births are not registered, where homes and property do not have deeds. Tokenization can also make the trading of financial assets more efficient and less expensive to all populations. So a blockchain like Corda, we can trade financial instruments directly between the buyer and the seller. And what we do with a Corda or Corda application is we update the Corda ledger directly. And again, tokenization can make financial asset transactions more available because they are, bottom line, they are less expensive and can be more efficient. So here we talked about the nature of transactions and how transactions involve updating a ledger. We talked about blockchain ledgers can update the same, so blockchains can update a ledger the same as any other party can update a ledger. Blockchains support asset tokenization, and any asset can be tokenized. And please take a look at our assessment. And additional resources. And please consult your training materials for your additional resources and for additional training. And next, we're going to talk about the essentials of cryptocurrencies. Thank you. Welcome to this lesson on Introduction to Blockchain Technology presented by Coding Bootcamps. The essentials of cryptocurrencies. Just to review, here is the information about our instructor and what we have learned so far. So in our last lesson, we learned about cryptocurrencies. Before that, we learned about smart contracts and building distributed applications and Truffle. Before that, we looked at mining and blockchain networks. And now we're going to talk about cryptocurrency fundamentals. So how are cryptocurrencies defined? So let's think about it for a second. A Bitcoin, Ether, EOS, what is that? Well, digital currency is some kind of a store of value. There are also digital dollars. May sound mysterious, may sound shady. It's not like cryptozoology. There are no secret assets. Cryptocurrencies are currencies that are insured by cryptology. Most cryptocurrencies, if not all of them, are highly divisible. And they are usually peer-to-peer. They're usually transacted peer-to-peer on an open ledger. And again, just like we have earlier, take a look at a blockchain explorer for Bitcoin and for other cryptocurrencies. Now you might say, well, are they all the same? And I believe we introduced the idea in our, I believe we introduced the point in our last lesson that cryptocurrencies all have their own specific use. Something like a Litecoin is highly secure cryptocurrency. So you don't even see the you don't even see their addresses. You see nothing about the transactions with a Litecoin. Something like an EOS. Well, what is that for? That gives you the more EOS coins you own, the higher priority your applications are on the EOS network. And with Ether, the more Ether you have, the more you can run or the more you can transact on the Ethereum blockchain. So cryptocurrencies defined, they have three properties. We can all see here, requires that that using an application in order to view, send, or receive money, so you need some type of application. Because these are digital, the application is secured by cryptography, and you have to be able to create and verify the transactions. And we have to be able to understand who owned the currency and who it's been sent to. And there needs to be some form of consensus. Usually, cryptocurrencies are transacted in an open blockchain. And we saw before that blockchains are distributed in nature. So therefore, we need some kind of community consensus to verify that all the ledgers agree. And there are many types of cryptocurrencies. So we all talked, I think we've talked about Monero, we've talked about Ethereum, Bitcoin, Libra we haven't heard too much about lately, but I understand the effort is underway. So each cryptocurrency is accessible on a running blockchain on the internet. The cryptocurrencies offer different features, so they all have their own little niche. And each cryptocurrency application has its own block time, consensus, transaction costs, and so on. Reprising assets. So assets, again, do something for their owners. So consider silver, gold, or other precious metals.
Thanks for watching. Feel free to add your questions as comments down below.
They can do something. So the more that they can do, the more valuable the asset becomes. Even a simple table in your garage can do something for you, in the future. So therefore it has some value connected with it. When an asset can do a lot for their owners, the demand for that asset obviously increases, which increases the price. Cryptocurrencies are valued by what they can do for us or what they can deliver for us in the future. Therefore, the value of cryptocurrencies is set by supply and demand. So this may be some of the true aspects of pure supply and demand left in the world. There, at least in most countries, there's very little to no regulation over cryptocurrencies as far as their value. So we talked about before, we can tokenize assets as cryptocurrencies. So tokenized assets and cryptocurrencies are not the same thing. Cryptocurrencies on a blockchain are the native token. So transacting in this native token on the blockchain is the most efficient type of money transactions for these blockchains. The native cryptocurrencies are the foundations of the applications that are running on the blockchains. So EOS, Ethereum, the Ether, they are all driving the transactions on their networks. Tokenized assets are created from a standard contract running on a blockchain. And all tokenized assets comply with the methods and attributes of that contract. So if we think about, again, an asset and we want to tokenize it, we have to think about those identifying characteristics or attributes that we can then build into the token that we're building. And the ERC20 is a smart contract, and it's not even a very long smart contract, but it incorporates within it the standards for tokenization. So you can find any asset around your house, around your work. And in theory, you could use ERC20 to tokenize it. I gave the example of a property. So if a property is worth $100,000, we can create 1,000 tokens worth $100 each. And then we then can go about and sell those tokens. So in order to have transactions in cryptocurrencies, the transactors need some form of digital wallets. And all wallets, not that there's a standard, but all wallets function in the same general way. They're a storage for the user's credentials, the ID information for the digital payment system. So your public key and your private key. So digital wallets facilitate spending and receiving the digital currencies and give you ownership and the currency balance. Now, you do not have to store any of your, say, your private key in your digital wallet, may be more convenient, but you can also enter it at the time of transactions. No currencies are ever downloaded to a digital wallet. All digital wallets hold identity information that provide access to your public and private keys for the cryptocurrency transactions. There are different forms of digital wallets. So a desktop wallet, like its name, it's stored on a desktop computer. Mobile, so there are apps that run on your smartphone. They tend to be very, very popular because they're very easy to use, very convenient. You can store your private keys online in what they call a web. So you have access, at least on the web, to your private key. You can have a hardware wallet, digital wallet, an offline device that can connect to the internet when needed. So it might be a USB key, it might be a USB device. You can also have a paper digital wallet. It's a printout of your QR code that can be scanned for your wallet information. Hot wallets are always connected to the internet. Cold digital wallets are never connected to the internet. So here's an example here of this. Looks like a mobile or an app digital wallet. And when you're transacting, when you're ready to receive a payment, the receiving party will provide his or her wallet address, usually through a quick response code. And then you'll enter the recipient's address into the recipient address field. And then, so this could have been taken by a scan, and the amount is entered, and we click confirm. If the QR code was scanned by your wallet, that's all that's needed. You just simply need to enter the amount. So your keys are still very long, and they can be very frustrating to enter manually, so that's why QR codes are quite popular. And cryptocurrency exchanges are available just about everywhere online. There are physical exchanges that you can go to. You can even be your own. So Coinbase is a very popular one. So a cryptocurrency exchange is a place where cryptocurrencies are purchased and sold. And the exchanges are regulated differently in the different nations in which they operate. Cryptocurrency wallet is needed to participate on the exchanges. So we just talked about that. We need access to your private and public keys. Cryptocurrency exchanges do not exchange the same list of currencies. So you have to go and look at those exchanges and see what cryptocurrencies are exchanged on that exchange. And cryptocurrency exchanges do charge fees for their services. Each cryptocurrency exchange has its own terms, its own fees, therefore you should investigate. So here's a list of some popular ones. Coinbase, I think still today is the most popular. Kraken, Gemini. You can download apps for all of these. Bittrex, Binance. These all have general good reviews, but when good or bad, these lists become dated quite quickly. So make sure that you do your research. I have Coinbase, and I'm perfectly fine with it. It works very well, very easy. A lot of cryptocurrencies out there. So consider how you would set up a cryptocurrency wallet. So this is what we want to do for our exercise. What are some steps? And here in our summary, we talked about some cryptocurrency fundamentals. We talked about the niche for each of the cryptocurrencies. We talked about cryptocurrencies as assets, transacting cryptocurrencies, and cryptocurrency exchanges. Please look through this assessment. And again, for more resources, consult your training materials. And for additional training, again, please consult your training materials. Next, we'll talk about the regulatory structure of the blockchain industry. Thank you. Welcome back to this Introduction to Blockchain Technology lesson presented by Coding Bootcamps. In this lesson, we're going to talk a little bit about the blockchain regulatory structure. And just to review some information here. So in our In our previous lesson, we talked about cryptocurrencies. Before that, we talked about smart contracts. We talked about blockchain mining, the structure of a blockchain, blockchain networks. So now we're going to talk about the blockchain regulatory structure. So the blockchain regulatory structure is highly, highly focused on cryptocurrencies. However, though, at the time of this recording, the blockchain regulatory structure is really just at the beginning. So, and this information can get very dated very fast. So I'm going to just talk about some aspects of the blockchain regulatory structure that we'll always see. So as we know, the blockchain cannot operate outside of a legal system. Now, it operates it is everywhere and it is nowhere. The blockchain network is throughout the world. It's global. Therefore, nations can regulate within their own borders, but we will probably see some kind of international type of laws or regulation. Some new parts of blockchain and cryptocurrency deal with know your customer and the ALM, which stands for the anti-money laundering. Because of blockchain and cryptocurrency's anonymity, it does create it does give tools to criminals. So that is something that has to be understood. And those honest actors using the blockchain and the cryptocurrencies must make sure that they adhere to the rules. If you're in a situation where you have to know your customer, you may have to take the requisite several weeks or days to research your customer. And we need to validate that we are not moneying or laundering money in any way. So regulations exist at different levels, international, national, state, local. So you have to be familiar with all of these regulations. Regulations always result in permanent employment for experts. So that's something to think about. So blockchain solutions are growing fast, and more regulatory bodies will get involved. The European Union, even the United Nations are involved in blockchain regulations and standards. Also, the ISO, the International Standards Organization, is also active in blockchain. Few things to know. In the US, the IRS it considers cryptocurrency to be property. So if you own any cryptocurrency and you have gains from the value of that cryptocurrency, that must be reported as income. And you need to pay income tax. You don't owe payroll tax, but you owe income tax on any increases in the value of your cryptocurrency. I can't answer what could happen if the value decreases. You may need to register as a money services business. You need to know this to understand depending upon what you do with your blockchain and cryptocurrency, you need to know, are you a money services business? So cryptocurrency exchanges are required to comply with the AML and also comply with the Financial Crimes Enforcement Network. So the Financial Crimes Enforcement Network is a federal bureau that safeguards the financial system from illicit use and threats to our national security. So as you can guess, the anonymity of cryptocurrency does make it tempting for bad actors. We see now we're in this age of ransomware, and anytime a victim, usually a victim of ransomware, gets a note that instructs them to upload, it's usually Bitcoin, to a certain address. So you can see there how bad actors you can exploit the anonymity of cryptocurrencies. So cryptocurrency sold as part of an ICO are utility. So are they utility tokens or are they security tokens? An ICO is an initial coin offering. If it sounds like an initial public offering, you'd be right. They're very, very similar. There are currently two types of tokens. I should say there are two types of tokens that can be offered in an ICO. So an ICO is where you tokenize some assets in your business and then you sell those as tokens or as coins to backers. So in an ICO, there are two types of tokens. There's utility tokens, which provide a specific access to your product. So it says here they are similar to loyalty points. Yes. Also, if you're familiar with any type of
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Games that have coins as prizes, or you can use coins to go to higher levels or buy items in your game, in your virtual world, you can sell those coins ahead of time. Those are utility tokens, and you can issue those coins and sell those to your users ahead of time. And then there's also security tokens, which would be investments, very, very similar to selling equity in your business. So it's very important that you consult an expert, because if you issue security tokens, you could be involved in selling in the selling of a regulated security without the proper authorization. So be very careful. Consult an expert. So security tokens can increase in value and also be sold to other investors. So very, very similar to any type of security. The ERC-20 standard is used for tokenization. And in the past several years, many firms have raised money using ICOs. ICOs have been successful and unsuccessful. And for both the issuing firms and for the token purchasers, there are still a lot of unknowns surrounding ICOs. So an ICO, ICO is a security token, or what is considered a security token, again, an expert should be consulted to make sure all the Security and Exchange Commission regulations are followed. A security token represents a valuable asset that can be liquidated. If the organization issues a security token, they must register and comply with all the SEC rules and standards. Again, consult an expert to avoid violations and trouble. There are some ways that you can test to see if you are issuing a security token. So in 1946, the SEC published something called the Howey test. And the Howey test can be boiled down to two questions. And if you answer yes to both, you qualify as a security token. So is the token being sold as an investment? So are users buying it in the hopes that it will increase in value as your company is more successful? And is there a manager upon whom investors rely? And state and other local laws. So in the USA, but in many other countries, several states have their own blockchain regulatory laws, and even localities within those states may have their own. So you need to do the research. There are several jurisdictions in other nations with their own blockchain regulatory laws. So quite often nations, states, provinces, and other jurisdictions have either unclear or conflicting laws. So be aware of that as well. So there could be, even within the same nation, particularly within the US, different jurisdictions can have conflicting laws, and you need to do your research to understand what you should do within an environment like that, how to operate within that type of an environment. And unfortunately, legal and regulatory expertise is needed, almost always needed, certainly advisable. It's the cost of doing business, and it's if you are safe rather than sorry, that's the way you want to go. If you're sorry, it could be expensive. So the blockchain regulatory environment is growing and changing, but Please do your research because it is rapidly growing and it is changing. Cryptocurrencies are property for tax purposes, and increases in value must be reported as income. And that is in many jurisdictions, not just the US. Cryptocurrency exchanges and miners are money services businesses. So understand money services businesses. Cryptocurrency exchanges are businesses that are subject to the FinCEN regulations. So please understand that. And tokens sold as security are subject to SEC rules. So take a minute to go through the assessment. And for more resources, please consult your learning materials. And for more training classes. Next, we'll talk about blockchain use cases. Thank you. Welcome to this Introduction to Blockchain Technology lesson presented by Coding Bootcamps. This is blockchain use cases. Just to recap information about our instructor and what we have learned so far. So far we looked at the regulatory environment for blockchain. We looked at cryptocurrencies. We looked at smart contracts, and we looked at distributed application development. We also looked at the blockchain network, and we looked at the hashing and blockchain mining, blockchain types as far as public and private. And now we're moving on to blockchain use cases. So financial services will always be a good use for blockchain. There are going to be more use cases for blockchain, but we're going to discuss some that are classic uses, which will be very good, interesting use cases for a long time to come. So many financial services firms and central banks are already working on blockchain projects. Blockchains can provide settlements in a less expensive manner. They can also, there are also several projects for security settlements, and they can also provide, we talked about this, services to unbanked populations, so less expensive transactions and even micro transactions for many, many populations throughout the world. Cyber and network security. So blockchain, the design of the blockchain can also provide important network security. So we know that the data on a blockchain is immutable and the blockchain is resilient. So these two attributes make it a great cybersecurity solution. And a blockchain is a distributed network, and it's less vulnerable to attack. So we talked about resiliency. We said how a blockchain runs on a distributed network. Now on blockchains where all the nodes are the same, if one node goes offline or one node has a problem, other nodes can step in and take their place. So it is very highly resilient. So a blockchain is highly available. If a blockchain is attacked, those nodes that are under attack can simply be disconnected from the network, and then the network can continue to function. Entertainment is also a great use case for blockchain. So video files, music files, image files can be encoded. Blockchain-powered with blockchain-powered file formats to ensure artists and others are receiving the right compensation. It ensures all parties are credited and paid. Ethereum already has file formats with metadata preserved and cross-checked for consistency at all stages. Energy, particularly the decentralized energy retail market. So this is a way of being able to get paid, transact and get paid for unused energy. So any excess energy can be sold to other customers, and customers can make payments on a blockchain using cryptocurrency. And supply chain. We all have heard about how blockchain is a great use case for supply chain. It is true. Walmart is currently using Hyperledger for its supply chain. Supply chains are usually made up of independent, disparate vendors with a common customer, so they have that one element in common. Other than that, they're probably just as happy not to share their data or any of their processes with their fellow vendors. The vendors only share some of their data, what's relevant to the customer. And all participants in the supply chain can input the required data, including locations, lot numbers, deliveries, with only visibility to the end customer. So the transparency of the blockchain makes all the data on it readily reportable, traceable, and verifiable. And if a problem is detected, again, it can be traced back to a particular lot or a particular shipment. Law enforcement. Enforcement is a great use case for blockchain. The immutability of the blockchain makes it ideal for things such as evidence tracking and also chain of custody. Blockchain can also provide immutable diaries or notes of the steps taken during investigations. And the transparency of the blockchain also provides advantages to the legal system. Identity management. So when it comes to identity management, there are many solutions offered. Identity metadata and attributes can be hashed and stored on a blockchain. So births can be registered. Licenses, again, can be managed on a blockchain. Other identity information could also be available, and when needed, only shared to those who need it. So your identity can become an asset. So very, very similar to the way that we're able to send a Bitcoin to one another, we can also send identity information to a particular user. Election and votings. So a blockchain can be a fair, inexpensive, secure, and transparent voting system. So in this particular case, each elector would have one vote token per office on the election. So if there's a congressman up for election, a mayor up for election, and a U.S. senator up for election, that would be 3 tokens. And then when ready to vote, the elector would send the ownership of his or her token to the supported candidate. So to the candidate for U.S. senator, to the candidate for U.S. Congress, and to the candidate for mayor. The blockchain would instantly tally the votes in real time, and the votes can be reported on at any time. Also, fundraising. So we talked about this as far as ICOs. So the ERC20 is a standard for smart contracts on, well, it says the Ethereum blockchain, but this can also be used on other blockchains as well. So we can tokenize assets, and the assets can be sold in a crowd sale model. This approach is called an initial coin offering, or ICO. ICOs are, well, the regulation is a little unclear, and firms are cautioned to consult an expert in ICO regulation before offering ERC20 tokens. Personal data and user attention. So if you go and look at the Brave web browser, it's a blockchain-based web browser and uses tokenization. It uses an Ethereum token, an ERC20 token called Basic Attention Token. So Brave creates links between the user, advertisers, and content creators, allowing interactions by token. Brave prevents advertising, but allows users to view only the advertisements they want to view. So this sends valuable information back to advertisers. It also gives a lot of options to users. So we are, in this case, the Brave browser, and please look it up, is tokenizing user attention. And then users receive payment in a cryptocurrency called BAT, Basic Attention Token, for their attention to advertisings. And advertisers do receive the data that the users have viewed. Record keeping, so the immutability and the permanence of the blockchain is great for storing deeds, licenses, birth and death certificates, marriage certificates, certificates of insurance, much more. Many times, what the difference between prosperity and poverty is paperwork. There are several examples around the world where one part of a village has a home, a deed for a home, though, and those the residents of those villages that have a deed are more prosperous than the sections of the village where the residents there do not have deeds to their home. And blockchain can very efficiently and easily provide that record keeping to make the populations more prosperous. Internet of Things. So as devices are connecting to the internet, and then
Thanks for watching. Please like and share this video.
and we don't even know, the IoT is considered to be greatly insecure because on these devices, nobody logs in nobody connects to our Wi-Fi's. It just happens for us. And so therefore, you can use a blockchain to help these devices log in. So the devices on the Internet of Things are vulnerable. So blockchain applications provide ways for the IoT devices to log in and also disconnect. Users are able to store information on Ethereum or other blockchains using private and public keys in order to access the IoT devices. Loyalty programs. So this is getting very, very popular. So loyalty points can also be tokenized. The blockchain loyalty applications provide greater flexibility, greater fraud protection, reduced program costs, increased availability, and other advantages if they want to make the loyalty tokens redeemable from other sellers. They can do that, and then you can get data actually on what your customers are doing, or the issuers of the loyalty points can get data on what their members are doing by tracking where the tokens are redeemed, so they can get a better understanding of their customers. Healthcare data. So healthcare data is always a difficult subject, but it's another natural use case for the blockchain. Patient data can be secured on Ethereum or many other blockchains, and then it can be made available to physicians and other healthcare providers. Simply, just like we send an asset to another user on the blockchain, we can do the same thing with our tokenized healthcare information. So we can send it to hospitals and other insurance companies, and we can also make our profiles visible as well. We can share that. And again, it is in the blockchain is unhackable and immutable. Smart cities. So there are blockchain applications that enable smart cities. So turning the lights on when it gets dark, managing traffic lights. So many cities have smart city programs. So the blockchain can provide for smart cities in a very efficient manner. Settling disputes. So we see this more and more. Blockchain applications can validate ownership, and they're secure, and they support digital signatures, very transparent, timestamps. So the blockchain has all that information permanently recorded. So blockchain applications can greatly aid in settling disputes. Advantages include saving public money and saving the individual's time and aggravation, saving courts time. So the summary of what we talked about: blockchain provides advantages in banking and securities transactions. The tokenization use cases: ERC20 for fundraising, please take a look at that. Entertainment and supply chain use cases. Basic attention token in the Brave browser. Please look this up, brave.com. I think you'll like the browser at least. Record keeping, voting, Internet of Things, loyalty programs, healthcare. You will see blockchain solutions. Maybe you won't even know there's a blockchain behind many of the solutions that we'll soon see in the future. Please view the assessment and complete the assessment. And again, for more resources, please consult your learning materials. For more training, please consult your learning materials. Thank you. Thank you for taking this class, Introduction to Blockchain Technology, a presentation of Coding Boot Camps. And we just completed an introduction to blockchain technology and how blockchain technology works. The topics we learned in this class, we had our introduction to blockchain technology. Along with our introduction, we learned how blockchain ledgers work, the structure and types of a blockchain operation and mining, blockchain cryptology, and blockchain consensus, and we looked at the distributed blockchain networks. We explored blockchain versus a relational database, first and second generation blockchains, popular blockchains and blockchain products, essentials of cryptocurrencies, cryptocurrency fundamentals, the blockchain regulatory structure, and blockchain use cases. Congratulations, you have successfully finished this class. For follow-up, please look into Introduction to Blockchain Cybersecurity. Look into Solidity programming, and also we develop many examples. Learn blockchain development for Corda, Hyperledger Fabric for developers, Ethereum blockchain development, Hyperledger Fabric for administrators, and Hyperledger Sawtooth for administrators. Thank you again, and please follow us on social media. We'll see you in the next class.